In the year 2000, the ground beneath these two towers did not exist. There was no soil here, no bedrock close enough to touch, nothing but 40 feet of open seawater in the Persian Gulf. And yet today, a pair of 550-foot towers shaped like two crossed swords rise out of that same water. And every single engineer who first looked at the plans said it could not be done. This is the story of how a nation built land out of nothing, then built two of the most structurally punishing skyscrapers on Earth on top of it. And if you think pouring concrete is boring, wait until you hear what happens when concrete gets hot enough to tear itself apart from the inside. Stay with me, because by the end of this, you will never look at a hole in the ground the same way again. It starts with a coin. A small, unremarkable, centuries-old Qatari coin engraved with two crossed swords, the kind of thing that sits in a museum case and gets glanced at for 3 seconds before a visitor moves on. Except one architect did not move on. He looked at that coin and saw a skyline. He saw two blades leaning toward each other, curving through the air, and he decided that Qatar's newest waterfront city needed to wear that symbol at 400 times the size, in glass and steel and concrete, permanently. There was just one small problem. The land those swords needed to stand on did not exist yet. So Qatar did something almost unthinkable. They built the ground first. Dredgers pulled millions of cubic meters of sand and sediment up from the floor of the Gulf and pumped it, layer by layer, onto the open sea until an entirely new coastline, 38 square kilometers of it, rose up where there used to be nothing but waves. An entire man-made peninsula, built specifically to hold a skyline that did not exist yet, for a city that did not exist yet, to celebrate a World Cup that had not happened yet. And here is the part almost nobody talks about. Reclaimed land is a liar. It looks solid. It looks like ground you can build a house on, let alone a 211-meter tower. It is not. Geotechnical engineers drove test probes into that new land and got numbers that should have ended the project on the spot. The top 20 meters were loose, freshly placed sand sitting on soft marine clay, soil so weak that if you tried to stand a garden shed on it, it might sink. Now imagine putting a 36-story hotel tower on it. The engineers had a phrase for what they were looking at, near zero bearing capacity, which, in plain English, means this ground could hold almost nothing at all. So the entire tower had to skip the ground completely and reach for something far below it. Solid rock, buried more than 30 meters beneath the seabed, the only material in the entire site strong enough to trust with 211 meters of concrete and glass leaning over the Gulf. And this is where the real fight began. To reach that rock, engineers designed 2,067 bored piles, concrete columns a full meter wide, drilled 35 meters straight down through sand, through clay, through everything soft, until the drill bit finally struck rock and stopped. Do the math on that for a second. 2,067 individual holes, each one as deep as a 10-story building is tall, drilled with almost surgical precision, into land that was open sea only a few years earlier. But here's the terrifying part. The moment you drill a meter-wide hole 35 meters into wet, reclaimed ground, the walls of that hole want to collapse in on themselves immediately. There is nothing holding that soil up. So crews pumped in bentonite slurry, a thick clay-based fluid that presses outward against the walls of the hole and keeps them from caving in while the drilling continues. An invisible, unglamorous fluid doing a job that, if it failed even once, could bury a drilling rig alive. Then, into that slurry-filled hole went a steel reinforcement cage, taller than a 10-story building, lowered down with only centimeters of clearance on either side. One wrong angle, one snag on the wall, and the entire pile is compromised, before a drop of concrete even touches it. And the concrete itself could not simply be poured from the top. That would cause the mix to separate on the way down, weakening the pile from within, so it was pumped in through a tremie pipe from the very bottom, forcing the wet concrete to rise up and displace the slurry as it climbed, guaranteeing a solid, unbroken column all the way up. Every single one of those 2,067 piles was then tested with sound waves, sonic integrity tests, listening for hidden fractures deep underground where no human eye could ever check. If the wave broke, the pile was rejected and re-drilled. No exceptions, no shortcuts, not on a tower this tall. Selected piles were even loaded to 1.5 times their design weight just to prove they would hold, and they barely moved a millimeter. 50,000 meters of piling went into the ground beneath this one plot. More steel and concrete buried out of sight than most bridges use above ground in their entire lifespan, and nobody visiting this building will ever see a single meter of it. But building down was only half the battle, because now they had to dig a 10-meter deep basement into land that used to be seabed, directly beside open water that was actively trying to get back in. To hold the Gulf away from the excavation, engineers used interlocking secant piles, Hard and soft concrete columns cut through one another like overlapping teeth, reinforced in places by a wall a full 1.5 meters thick. And then, during construction, it happened. A leak. Water found a crack in that wall and began pushing through, and for a moment, everyone on that site understood exactly what was at stake, because one small breach under enough hydrostatic pressure does not stay small. It grows. Crews responded immediately, injecting expanding grout directly into the crack, watching it foam and swell and seal itself against the pressure of an entire sea trying to get in. Then came the part nobody sees on any highlight reel. Dewatering pumps that ran, without stopping, for over 12 months straight, continuously draining groundwater out of an excavation. Site the size of nearly 20 Olympic swimming pools, just to keep the hole dry enough to work in. Every single day, surveyors measured the movement of the retaining walls, because a shift of even 20 millimeters was enough to trigger an emergency stop on the entire project. Stop and think about that for a second. 10 meters below the surface, on ground that was open ocean 5 years earlier, held back by concrete teeth and a year of nonstop pumping, engineers were building a basement that had to be watertight forever, because if that membrane ever failed after the building opened, there would be no draining a flooded foundation. The 400 millimeter basement slab they poured was reinforced with 2 complete mats of steel, bound together by hundreds of connecting links, and poured in a single 16-hour continuous run. Because if the concrete set unevenly and created what engineers call a cold joint, that seam becomes a permanent structural weakness in a wall meant to hold back the sea for the building's entire lifespan. With the basement sealed and the foundations finally trusted, the towers could begin to rise. But rising was never going to be simple, because these towers do not stand up straight. They lean, like 2 swords crossing, curving outward as they climb, which meant that, literally, no 2 floors in either tower are the same shape. Not one. Every single level required its own unique structural plan, its own unique formwork, its own unique steel layout, an almost unheard of level of complexity for a building this tall. At the heart of each tower sit 8 massive reinforced concrete cores, the structural spine the entire. Building hangs from, and to build them, engineers used a self-climbing formwork system that essentially crawls up the building on its own, using hydraulic rams to push itself upward off the very wall it just poured, one level at a time, without needing a single crane pick for the climb. Because the towers lean, the formwork panels had to change angle on every single floor to match the curve, wedge-shaped panels compensating for a building that never stops shifting its lean as it rises. And then there is the heat. In the middle of a Qatar summer, with daytime temperatures pushing past 45 degrees Celsius, high-strength concrete generates so much internal heat while curing that it can crack itself from the inside out before it ever gets the chance to hold a single ton of weight. On one of the deepest transfer beams in the entire structure, the concrete core, temperature climbed to 71 degrees, just 1 degree over the safety threshold, and for a moment, engineers were staring at the possibility that one of the most critical load-bearing beams in the entire tower could split open from thermal stress before it had even finished curing. The response was immediate. Chilled water pumped through pipes laid directly across the beam's surface, physically cooling the concrete from the outside until the internal temperature dropped back under control. 1 degree. That is how close this building came to a hidden structural wound that nobody would have seen until it was already too late. Above that beam, an entire forest of steel props held up the load until the transfer structure gained enough strength to stand on its own, and then, one by one, engineers began removing those props while measuring exactly how much the beam flexed under the strain, a slow, deliberate transfer of trust from temporary steel to permanent concrete. Meanwhile, above the climbing cores, an entirely separate army of workers was racing to keep pace with custom aluminum formwork. Tables, over 10,000 square meters of them, each one manufactured individually because, again, no 2 floors share the same shape. These tables could be raised 2 full levels at a time without a crane, cutting the slab construction schedule dramatically, and every time a pour went ahead, 90 cubic meters of concrete an hour, roughly the weight of a double-decker bus every 10 minutes, flowed onto floors that had to come out perfectly flat because even a slightly warped floor means doors that will not close and tiles that crack within a year of opening. Thermal drones scanned every single freshly poured slab, hunting for hidden hot spots invisible to the human eye. On the long-span floors, engineers threaded steel tendons through the concrete and tensioned them after the pour, locking 19 tons of compressive force into a single cable to stop the slab from ever sagging under its own weight. Floor by floor, the crescent shape of the sword began to emerge in real concrete, curved steel beams manufactured off-site to match a digital model down to the millimeter, swung 12 tons at a time by crane, 50 meters above the ground, and caught by ironworkers with nothing but a steel bar and raw nerve. By the time the final lift of concrete was poured on the roof of the core, 18 hours of continuous pouring in the dark, 211 meters above the waters of the Gulf, a final survey came back with a number that still seems almost impossible. After everything, after the leaning, the curving, or the heat, the thermal stress, every single core wall was found to be within 8 millimeters of its exact theoretical position across the entire height of the tower. 8 millimeters, over 211 meters. Then came the skin. 5,000 facade panels went onto this building, and not one of them is the same size as another. Each pane of curved glass was bent at over 650 degrees Celsius to match one single specific location on the tower, and every one of those panels traveled from the factory GPS tagged so that the crane operator knew its exact destination before it ever left the ground. Because on a project working toward a fixed World Cup deadline, a single misplaced panel could cost hours of lost crane time that nobody had to spare. Each unitized panel clicked directly into a bracket already cast into the slab edge below it, built with just enough tolerance to move slightly during Qatar's punishing thermal swings, without ever cracking. Every single bay of that curtain wall, all 36 floors of it, was water tested before being signed off, because it only takes one missed seal to eventually rot a building from the inside. And then, one afternoon, the safety netting finally came down, and for the first time since construction began, 2 full towers stood completely exposed against the sky. 2 swords, unmistakable, catching the light exactly the way that small ancient coin once did. But a tower is not finished when it looks finished. 4 industrial chillers together, capable of 8,000 tons of cooling, had to be pressure tested at 16 bar for a full hour, because even the smallest pressure drop meant a hidden leak somewhere buried inside 36 floors of ductwork. Every sprinkler head, every fire alarm, every single one across every single floor had to be tested, because a fire suppression system inside a 211-meter hotel does not get a second chance if it fails. And then finally, 33,000 volts of electricity were sent into the building for the very first time, and by every account, every engineer on that site held their breath in the same instant, waiting to see if 4 years of impossible engineering had actually worked. It had. A structure that began as an idea stamped onto the surface of an ancient coin, built on land that was open sea within living memory, standing on 2,067 concrete lifelines, buried 35 meters into rock, now stands finished, tested, and occupied. A building that, on paper, should never have been possible on this ground, in this heat, on this timeline, and yet here it is. If a story like this is the kind of thing that pulls you in, the next one might do it even harder, so stay close, because we are not done building impossible things yet.